Students, myself Professor Ankur. I welcome everyone for the GATE theory session on analog circuits. Today we are going to cover an important topic in operational amplifier, that is square wave generator. This is our second session on operational amplifier. Let's start with the session. So the main thing we need to understand here is we are going to use op-amp as a basic oscillator circuitry here. That's the reason if you see the circuit diagram carefully, there is no voltage source connected to the circuitry. So it will operate on the concept of comparator, or you can say similar to the logics of Schmidt trigger hysteresis. So the circuitry will be having a control voltage that will be defined by the non-inverting pin of the op-amp, and the operation will happen with respect to the charging and discharging of the capacitor. So the charging and discharging path of the capacitor happens through the resistance RF, and the output of the op-amp will be either plus Vsat or minus Vsat. So now when we talk about the basic operation, we are assuming that suppose the output of the op-amp is plus Vsat at the initial stage. So we can take R2 and R1. So we can define the value of the reference voltage that will be controlling the non-inverting pin. So the reference voltage can be defined as R1 into Vsat divided by R1 plus R2. Going back to the circuitry. So the top point of the voltage is going to be plus Vsat. Output is plus Vsat. So we are taking the drop across R1 as Vsat into R1 divided by R1 plus R2. The current going inside the op-amp is as good as zero because that's a property of op-amp. The internal resistance is very, very high. So whatever current flows in the path of R2 and R1, that current will be actually as good as a current flowing through a series resistance set. So that's the reason the value of the reference voltage created will be defined as Vsat into R1 divided by R1 plus R2, which is also called as the upper threshold point or the plus reference point. So since the output of the op-amp is positive Vsat, the capacitor will start charging. So as soon as the capacitor reaches the potential which is being set as a reference level by the positive pin, so if the voltage slightly crosses, so the V minus pin voltage slightly crosses the value of V plus pin, automatically the op-amp output will go to minus Vsat. If the op-amp output goes to minus Vsat, the reference voltage that will be created now at the plus pin will be negative because the value of that voltage will be minus Vref or the lower threshold, and it will have the value minus of Vsat into R1 divided by R1 plus R2. And because the voltage being negative, now the capacitor will start discharging and losing the energy. So it can lose till the value of the lower threshold point. So as soon as the voltage of the capacitor just falls slightly below the lower threshold point, again the plus pin of the op-amp will become greater than the minus pin in terms of potential, and the op-amp output will become plus Vsat. So if your observation is sharp, we come back to the initial stage, what we were actually starting the operation from. So this operation will keep on continuing, where the output will keep on switching from plus Vsat to minus Vsat, depending on the charging and the discharging voltage of the capacitor. So as I've discussed that there are two reference voltages, the upper threshold and the lower threshold, where the upper threshold value will be R1 into Vsat divided by R1 plus R2, and the lower threshold value will be R1 into minus of Vsat upon R1 plus R2. So the output of the system will be switching from plus Vsat to minus Vsat and minus Vsat to plus Vsat as and when the capacitor keeps on charging and discharging with respect to the reference levels that is defined by the upper threshold and the lower threshold. If you keep the upper threshold value and the lower threshold value such that both the resistances R1 and R2 are same, then automatically the upper threshold value will become plus Vsat by 2 and the lower threshold value will become minus of Vsat by 2. So that purely depends on the combination of resistor that you select during the design to get the value of upper threshold and lower threshold. Now, since we want to get the equation for the capacitor with respect to the time period and frequency of the wave, our main target is to obtain the time period or the frequency of the output waveform. So for that, we are going to use the equation of the capacitor. So all of us are aware that the capacitor will start charging from the lower threshold and can go till the upper threshold and again start discharging from upper threshold till lower threshold. So if we just consider one of the cycle with the main equation of the capacitor defined by Vc of t is equal to V max plus V initial minus V max e raised to minus t by tau. That is basically the time constant R into C. So now when I define the value of V max and V initial, the initial charging effect starts from the lower threshold and the maximum it can charge is plus Vsat. So that's the reason the maximum voltage that the capacitor can charge is plus Vsat. And since we are considering half of the cycle, so here the initial value will be the lower threshold value. So the equation gets modified that whenever we are talking about the charging of the capacitor can charge maximum up till the upper threshold. So that's the reason. So Vc of t can go max up to upper threshold. So the value is Vut is equal to plus Vsat plus lower threshold minus of plus Vsat e raised to minus t1 by Rf into C, where Rf into C is basically the time constant for the capacitor charging. So now we can rearrange the equation. On rearranging the equation, you will get e raised to minus t1 by Rf into C will become plus Vsat minus upper threshold divided by plus Vsat minus the lower threshold. So now we take log on both the side and shift the terms Rf C1 with the minus sign on the other side and compensate the minus sign in the log function. So you get the value of Rf into C plus Vsat minus lower threshold upon plus Vsat minus lower threshold. So this is basically the value of your function T1. So T1 is going to be Rf into C log of a function value, where the upper threshold and the lower threshold are defined in terms of R1 and R2. So now the total time period of the wave will become twice of t, because the impact of charging and the impact of discharging is going to be one and the same, because this circuitry is going to generate a square wave type oscillation where the time taken by the capacitor to charge is going to be equal to the time taken by the capacitor to discharge. And that's the reason you will find that the total time period will become twice of the value T1. So it will become twice of Rf into C log of plus Vsat minus VLT divided by plus Vsat minus VUT. So now if I want to get the value of frequency, the frequency value will be inverse of the time period. So this is how you can understand that the op-amp can be used as an oscillator, or we can say a square wave generator. If we give the waveform of the capacitor to a smoothing filter, automatically that waveform can be or may be converted into a triangular type behavior also, or a sinusoidal type behavior also. That depends on the way we are trying to go for the wave shaping of the signal. So overall, if you observe, this circuitry was specially designed to generate square wave type output from op-amp circuitry. Thank you.